Yo, what's up, what's up, what's up? Welcome back. Today, we're looking at reading video frames from a webcam in Linux. So I think that there's this thing, v4l2, which is like the Linux interface in the kernel for getting video from stuff. v4l is like video for Linux. And if I understand what I've briefly skimmed correctly, it looks like there's some file handle that I can like look at in dev video. And these get registered for each video input, if I understand correctly. And I should be able to like interact with these files in some way that gets me the stuff that is in my webcam. And I don't really understand how any of that works right now, and I just thought it'd be kind of interesting, and it might be useful for like some project at some point. So I think that's what we want to get done today. And so there's not really much background knowledge that I have right now. I think we're just gonna have to like do some reading, do some maybe like pull an example and kind of start working through it, and then trying to do it on our own. And maybe I'm hoping that we can get to the point where we're like showing frames in some sort of UI. And just kind of seeing what happens. So let's start, I guess, by looking at the Linux kernel documentations has this like C example. And I think I just want to like copy paste this whole thing and like run it and make sure it works. And from there, then we can like start looking at like the actual docs and figuring like what the fuck this thing is doing. And trying to integrate it into our own app. So you can say like this, and maybe we say we are doing run example from Linux kernel docs. And this was at around like 0200. Okay. So this thing's saying that the device is busy. So I might have to actually turn off the webcam in OBS. Maybe. Let's try that. Delete the webcam. Would I like to delete the webcam? Yes. Is that not working? Oh, maybe I have to hit this button? There we go. Okay, yeah, there we go. Okay. Device or resource busy. That's annoying. What does this thing? Why are they showing dash backslash ends in here? Did we double backslash new lines? Let's just fix that real quick. GCC initial test. Device or resource busy. Okay, so I did try this on my like normal account the other day, and I could read the device. So this is surprising to me. Let's do /test -- help. Oh my god. Is that... What have I done? Why is this, like, not new lined? Hello? Like, video device name. I think I fucked this up. %. So, maybe the double backslash was correct? No, I think I just fucked up. Oh, this is just broken here as well. This example is just busted. Okay, fine. We will fix this as well. So there's a bunch of ends in here that are supposed to be escaped and they're not. Which is cool, which is super cool. Not that this matters, but I just want to be able to fucking read what I'm seeing. Where is it complaining there? 579. Did I make a mistake? 579. I did just put a K there by mistake. Okay. So we run help. There we go. And test-d dev video 0. Device or resource busy. Why? Why? Imagine if multiple processes couldn't get frames. Well, I think I read in the docs that that's actually true, that only one reader is technically supported. But I did think that if I just killed the camera on my stream, then it would be fine. Pipewire, wire plumber, OBS, FFmpeg. So it looks like even though I've removed the thing from OBS, it's like still showing it. That's fucking. He's probably still reading it. I wonder if I can kill that. PS aux grep OBS. It does seem kind of sketchy. But also it doesn't, like, my computer, like my webcam doesn't think it's on, which is kind of odd. Kind of odd. I should have, let's see. Let's just do a couple scene transitions to see if that will adjust anything. Oh, that's so annoying. Can I, like, force it? Where is this coming from? Where is this coming from? So this is saying probably when we try to create this thing. Vid IOC rec buff fs. Okay, well, I guess we can just start looking at what the fuck that means. What does that mean? Return value. Generic error codes are in the generic error code. So octal can't be handled because the device is busy. When the device is streaming, an octal tried to change something that would affect the stream, or would require usage of the hardware that is already allocated. The octal must not be recharged without performing another problem without. Sorry, the octal must not be retried without performing another action to fix the problem first. Oi, oi, oi. Okay, well, maybe we just see if the stream fucking dies if I kill that process. And just hope for the best. And if the stream goes down, I'll be back in like 2 seconds with it back up again. Recording stopped. I think we're back. Stream didn't die. So it looks like, I guess, while recording, FFmpeg, like OBS must hold the webcam and like not remove it for some reason, which is kind of odd. But whatever. Okay. So we have like a test thing that's doing something. And what the fuck is this thing trying to do? Why? Oh, maybe it was because... Here we go. So, I guess we read the -- help to see. And it doesn't really say what it does, but we can output stream to std out. Okay. So I guess if I run like test-o, this is gonna like fuck up my terminal, probably? Yeah, okay. Oh god. We'll just kill that and start over. Okay. So we have some example that kind of works okay. And so now I guess we can just start trying to actually see what the hell it's doing. And just type reset next time, I'll fix the TTY. I wasn't really convinced that I was at a spot that would work, but yeah, I usually do that. Okay, so here they start by opening a device, and all they do is open dev video 0. Then they just, I guess they check if it's there, whatever, sure. This is just opening, no big dealio. So they open the thing, they initialize it by running some, what is X ioctal? I've seen ioctal, I've never seen X ioctal, so what the fuck is that? No manual entry. That's sick. Maybe X ioctal is something that they define? Ah, it is. Which is just, they are wrapping the ioctal with like a retry loop in case things get interrupted. Sure, that's fine. That is fine. So when they initialize the device, they say, hey, can I use you? Probably. Video IOC query cap. Opening and closing devices, querying capabilities. So they check if it is a compatible device and query the functions and IO methods supported by the device. Okay, that's interesting. And then they say, hey, we want these things. I see. So if you are using read, which is like basically like reading from the device into a buffer, they say you need to support read write, and I guess cap streaming means that you can just like map a buffer directly in. That's kind of cool. Yeah, so what is this? What is this? Cap streaming. Cap streaming. This device supports the streaming I/O. Oh, this is interesting. Okay, so there's like read write, async I/O, read write, streaming. And what is like streaming means what? There are two streaming methods. Blah blah blah. So we have memory map. Stream I/O is the method where only pointers to buffers are exchanged between application and driver. The data itself is not copied. Memory mapping is primarily intended to map buffers and device memory into the application's address space. Oh, that's pretty cool. Device memory, for example, the video memory on the graphics card with the video capture add-on. Neat. Being the most efficient I/O method available for the most time, many other drivers support streaming as well. Okay, so this is just more efficient than like the normal read-write API calls, I guess, because instead of copying the data off the video device and putting it in a buffer that you hold, instead you just have like a fucking pointer to device memory, I guess, is kind of what they're saying. Although with a USB video like webcam, I would be surprised if that's possible, right? Because like if I am requesting data from the USB device, from our like operating system development experiments, we kind of have a feel that like you say, hey, give me some stuff, and then it gives you some stuff. So I don't think that like USB has access to the memory bus like that. So I wonder if we can even do the streaming API. It'd be interesting to see if we can run test with the streaming API and see if like with mmap. Okay, that does work. But I would imagine, my guess would be that that's not any more efficient than the read-write API. But maybe it is. Cool. Sure, okay. So they do that. There's no repo command or GitHub command. There's no commands in my chat at all, but there is a link to GitHub in the description where all my projects go up. There isn't like a GitHub associated with this yet because we've just started, but it's there if you need it. Okay, so what is crop cap? Crop cap. So they ask basically, hey, what type of crops do you support? No. They call an ioctl, where ioctls I think are just like out of band communication. So if you have like a device node, you can like read or write, or you can like call a like configuration command. I assume ioctl stands for IO control. I don't actually know. Control a stream's device. Yeah, so CTL must be control. Okay, so they like do some like crop checking, then like some stuff that we probably don't have to worry about. Okay, easy. And then they're start capturing. They, for read, they do nothing. Okay. And then their main loop is just wait for the file descriptor to have some data in it, then read a frame, where read frame probably depends on the IO type, and they just do read. Okay, and then they process the image, which is probably just do nothing. Cool. All right, so yes, okay, so this is pretty straightforward, actually, to be honest. We should be able to bang out something pretty quick here. We can start with the read-write API, and if that doesn't feel good, then we can switch to mmap. But like, yeah, let's just start with that. So let's start a new Rust project. We need a shell that has Rust available to it. And we can just do cargo init bin. Okay. And oops. I need to close this Vim so that it doesn't think that there are two open. And let's see. We're gonna start read. I guess this is just read frame in Rust. Or maybe we'll start with open device and configure in Rust. That seems reasonable to me. No, see today, just a little bit for the example, but I think that I want to be working in Rust mainly. So we do need these like video for Linux types, I guess, probably to like control the device, right? We need these like v4l2 capability, v4l2 crop cap, v4l2 crop, etc. And I was looking at there's wrappers for like Linux API calls in Rust in like the Nix, right? I think they call it, where they have things like if I want to call ioctl, like they do have this call, but I was looking for like v4l types in here and I couldn't find any. So I think that we're just going to go the route of generating bindings for the stuff that we care about with bindgen, and then if we need something else, then we'll look for a crate that wraps it for us. Why don't you settle with C? Oh, I just prefer working in Rust. It's like it's where I feel more comfortable, and then also I think that I'll probably be if I'm doing this in the future, I'll probably be integrating with other Rust projects. So yeah, I don't know. It sucks. Like C's okay, but it's missing a lot of the like stuff that you would want to like do anything. Like the fact that it doesn't even really have a vector, and you have to like do like a realloc shit yourself. It's like, it's just like you don't even have a vector. Rust has like a lot of like useful shit in its standard library that I like, and it's like things like their enum types are just like they're just nicer. It's more fully featured, I feel like. But yeah, no, it's just preference. It doesn't fucking matter. Okay, let's pull in bindgen and generate some bindings. Let's generate some bindings. Where's their like example thing? Bindgen users guide. Here we go. Here we go. And then this is the build RS that I probably want. Something that looks like this. Something that looks like this. And we have to cargo add a build. I think it's called build with bindgen. Cool. And then we look here. So this doesn't matter. We don't need any like libraries linked because this is like just a Linux syscall thing. We do need our wrapper header script to tell us where to get our bindings from. I don't think we need this. We do need this, and then we need to write these out to somewhere. So we'll call this to v4l2 bindings. Cool. So let's include whatever we needed. Linux video dev 2 is probably it. And we probably need sys ioctl as well, almost certainly. Okay. Okay. Cargo build. And do we have the bindings that we need? Build out. Okay. So we have the ioctl call, and we probably have v4l2. Like, what were some of the examples of stuff that we wanted? Sorry, we wanted v4l2 buffer. We wanted v4l2 capability. Capability and buffer. Capability and buffer. Let's make sure that those are in here. So v4l2 buffer. Okay, yep, and v4l2 capability. Yep, cool. We have what we need. We have what we need. So now we need to make our file that pulls in the bindings. So we'll call this v4l2 rs, and I actually want it to be a directory up. Okay. So v4l2, and somewhere they're gonna say, here's how you do that. And we called this not bindings, but v4l2 bindings. Something like that. And in main, we should be able to say mod v4l2 and cargo build. Not quite right. So what do we call it? We called it, oh, dash, not underscore. Of course. Of course. All right, we built. Hell yeah. And then we can say allow unused here, so it doesn't fucking warn us about everything. Cool. Okay, so what do we want to do? We want to like open our device. So for now, we'll just assume that the device name is dev video 0, and we can fix this to something else later if we feel like it, but for now we can do that. We just want to open the file, so we're going to say let f is equal to, we probably need to use open options here, use std fs open options. And we can open options new. We probably, do we need like write permissions on this thing? So let's see what they did in CLand. In CLand, when they opened it, they opened it with read, write, and non-block. But non-block looks like maybe not required because they put a comment on read, write. So we'll say read true, write true. And I guess we'll open device name, and for now, unwrap. And if we cargo run this now, we do see no crash there, where if we were to try to open dev video 9999, that should crash. It should say, yep, we don't have that thing. So it looks like we successfully opened the video handle. We'll call this video handle. Then, what am I looking for again? I'm trying to see what we do next. So we have the thing, and now we want to look at like their device initialization. So the first thing they do is they call an ioctl to query the capabilities of the thing. So we can say let capabilities is equal to v4l2 capability, and maybe I'll just use v4l2 star here, just like fuck it, you know, just because that might be easier for me. And do we care? I guess we can use this as like a maybe an initialize type because we know that the system call is going to initialize it for us. So we can use what is it? It's mem maybe uninit. And so then we say this is a maybe uninit. Maybe uninit. No, uninit. And we have to probably flag the type here as v4l2 capability. Are you using some sort of language auto-completion language server protocol? Yeah, this is just using Rust Analyzer under the hood. I think I can see LSP info. It's just using Rust Analyzer, and then that's hooked up to like some Vim plugin that handles the I think it's nvim comp CMP that's doing the auto-completion for me. It doesn't like the generics here. So maybe I just say this is a maybe on init v4l2 capabilities. I already forgot it. Capability. Okay. So let's say now that we want to read those things from the device driver. So we can call v4l2 ioctl. And we pass in the video handle, but we need the file descriptor manually. So I think that there's a way to like pull that out from the file in Rust. File, Rust. Nope, wrong one. This one. And I think we can like as raw fd. Yeah. Let fd is equal to video handle as. What is the difference between as fd and as raw fd? What is the difference? As fd borrows the file descriptor. As raw fd extracts the raw just file descriptor. This function is typically used to borrow the unowned file descriptor. When using this way, this method does not pass ownership of the raw file descriptor to the caller. However, borrowing is not strictly required. Okay, I guess I'll just use... But, like, as raw FD, I don't think moves it out either. I think as raw FD, you probably just get an integer thing. I think probably as FD, they're probably flagging to the type system that you have to keep this for the, like, duration of... Like, you can't drop the original thing, maybe, while this is borrowed. So maybe that's fine. And this is use OS as FD as FD, sure. So here we can say we take the file descriptor, and I already forgot the call we were trying to do, something query capabilities. So here we were saying video vid IOC query cap, which we don't seem to have defined. So where does this come from? I don't have a language server for C set up right here, so that's kind of annoying. I guess we can install one. So we can say next shell -p clang tools to get clang D up and running so that I can jump to where the fuck that thing is defined so we can put it in our includes. So LSP info, is it running? Looks like it. And we were looking at the init device, jump to definition, working, sick. And jump to definition, working, sick. This is coming from Linux video dev 2.h. Okay. So, which I included. So why is that not, the bindings are not getting generated for that, which is a little annoying. Target, debug, build. Oh my god, which one of these is it? Target, debug, build, out this. So, vid IOC. Yeah, I don't understand why that's not getting generated. It could be that, vid IOC. I already forgot. Vid IOC query cap. Let's pop. What is this, like, IOR thing? This is... It's possible that this is, like, not getting resolved correctly, or maybe it doesn't like this if we don't include ioctl.h as well. Maybe. That seems possible, so let's look at the wrapper. What the heck? Oh, I'm in the wrong folder, that's why. So we can, oh, we do include ioctl. So it's possible that he's just not resolving, bindgen is just incapable of resolving those, which would really suck. Bindgen ioctl defines. Let's just see if somebody else has hit this. C macros not expanded. Yeah, okay. Is this, does anyone have a workaround? Fuck. So he just doesn't evaluate the macros. Oh, that sucks. That sucks. Okay. How do we work around this? I guess we just do we just bang out, duplicate the thing? v4l2 ioctl numbers. Maybe somebody else has expanded them for us. Maybe. No, it's not. Not so simple. Well, that's annoying, but we will live with it. Maybe this is one of those times where I should just, like, bite the bullet and do it in C. But now I want to know. Make a little C header, then use GCC to expand the macros for you, and then just do that. Oh, that's not a bad idea. Yeah. You could do, like, gen v4l2 ioctls. I mean, even then, I don't even have to do that. I can just printf them. So you can do, like, int main void And we can go in here and we can pull in this guy. And we can just say, and include stdio. And then what? We just printf for each thing we want. We can like define print ioctl number. Yeah. We take in the like number. And we can just say printf like this. Printf sd and then take in n, which I think, how do you turn things into a string in macros? I think it's with a dollar, like a pound sign there. I think it's something like this. And we can say print ioctl number vid ioc query cap or something, which doesn't seem to exist. Hello? Vid query cap. Vid ioc underscore query cap. GCC-o, or we'll say GCC-o gen v4l2 ioctls.c, or gen v4l, yeah, like this. And he doesn't like that this should be a long integer. Okay. So now we get a little crazy with it. We say this is an i32 i64 u64 is equal to like this. GCC. Okay. Hell yeah, baby. And then we put a semicolon here. And then we can copy paste this into our Rust code. We'll take it for now. We will take it for now. And then what we could get, we get really crazy. And what we could do is we could compile this generator in our build script, then run it in our build script to generate bindings that Clang is unable to generate for us. Okay. So then we pass in capabilities as mute pointer, probably. And we say this is mute. And he doesn't like that for some reason. Because he expected an i32, but it's a borrowed FD. So can I just like into? Maybe? He doesn't like that. Borrowed FD. So how the what's the point in this borrowed FD if he doesn't give me, if I can't fucking get the file descriptor out of him? Okay, we'll just do as raw FD here then, I guess. And here we go. Okay. Cargo check, cargo run. Okay, so nothing is being destroyed. We say now we have like capabilities is assumed to be initialized now. And this probably also has to be unsafe. So we can actually do this. We can say let capabilities, it's equal to this. We can put all of this inside an unsafe block and then get the capabilities out. And there we go. And then we can say print line capabilities. Is that actually going to work? I'm assuming that it's not. Oh, that's kind of cool. So I guess all structs automatically get debug implementations for them with bindgen, which is pretty sick. Okay, so now we have driver, card, bus info, version, capabilities, device caps reserved. Okay. So what were they doing in their test.c? So they asked for the capabilities somewhere. Init device. So this might fail. Right, so we have to handle this. So maybe we can say function run ioctl. If I define ioctl, it'll name collide. So maybe it does make sense to not just use everything at once and actually type v4l2 where we want it. And we can say function ioctl is going to take in all of the same things that the normal ioctl takes in, but he's going to fuck. We can't do that. We can't do that. We can't do it because I don't think that we can run. Oh, maybe we can. Let's try it. 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 So we'll say function ioctl. I don't know how like Rust variadics work, but we can see. So all I want to do here is instead of returning an int, I just want to return a result. For now, we'll just do nothing and nothing. And Rust variadics. I actually don't know if you can like using a macro makes a lot more sense here. Because I don't know if you can like reference the arguments here. Okay, so we'll say instead. Instead we'll say macro rules octal. Okay. And in here, we're going to say what? We're going to take in a fd num. These are both expressions. And then we're going to take in other arguments. So I think you do like args like this or something. I can't really remember, but we'll find out very quickly if this is wrong. And then we pass in here fd num and something like args like this something like this. I can't really remember. I'm gonna have to look it up. We have to look it up. So it's so you take in the thing, you put your $sign and then the comma and then a plus. I thought it was maybe a star here is what I want. Okay. This macro rules goes here, the exclamation point. Okay. And I need the star here as well. And args is also expression. Okay, that compiles, and then we should be able to say here, instead of doing this, we can say, just replace this with the ioctl macro. Okay. Expected expression. So he doesn't like... Maybe it is like this. Num expressor is followed by args expressor, which is not allowed for expression fragments. Are you shitting me? Oh, because I forgot a comma here, maybe. But then do I always have to have the comma? Whatever, it's fine. It's fine. Okay. So now we can wrap this with a... we want to put this in a block. And we want to check for a failure here. So we can say if... well, let's look at the man page for ioctl. I think that he returns -1 on failure. Yeah, instead no. Okay. So let ret is equal to this. I actually already forgot. Is it 0 on success? Ioctl will return any value that's not -1. Okay. So... Well, I guess we'll make like ioctl will be a result that is either a I32 for the correct answer or no on the incorrect answer. So if ret is equal to -1, we say and the error is the, I think it's std io error last OS error. I think it's how you get no, if I remember correctly. And otherwise, we say okay. okay with red. And here we can say let red is equal to this, so that we can give it a type, which is going to be result I32, I32. And expected I32 found error. Okay, so what is... I might be forgetting how to get error now out of this. Last OS error in Rust. I'm pretty sure. Oh, this gives me an IO error. Okay. That seems fine. So this is going to be stood IO error, like this. And there we go. So now we can unwrap this, and now we can assume it succeeded. All of that. Just to assume. Okay, cool. Okay, so we have got our capabilities, and what are we supposed to check on them? I guess we want to check that we are capable of reading the device, and that it is a video capture device. Okay. Do we have that? v4l2, v4l2 cap video capture. Okay, so these are working fine. So assert capabilities dot capabilities and this guy. Cargo run, so he doesn't like that I'm this. I have to do in Rust say this is not equal to 0. And that succeeds, cool. And then we also want to check the read-write API. v4l2 cap read-write. Oh. So he actually doesn't have the read-write API? So if I do test-r here? Ah! Interesting. Okay, so that's kind of the opposite of what I expected, to be honest. I expected that this USB device would support read and write, but not support mmap. Okay, so it looks like we actually have to support use mmap to get this. Or what is method user pointer? How do they use this guy? They on read, they call this like octal DQ buff with their buffer that they pass in. This looks very similar to mmap. What's the difference? Where does their user pointer come from, I guess? v4l2 buffer buff, okay. Oh, I see. Here they say, I want this thing to be mmapped. And I guess are we calling mmap anywhere in here? Init mmap. And init user pointer. What's the difference? So for init user pointer, we create some buffers. And then do we like assign them to, do we never hand them off to the driver? So we say, hey, we are requesting some buffers. Oh, I see. So we either request, the allocation comes from the driver. That's kind of interesting. And, okay. I see. So here, they're saying, I'm going to, hey, video driver, I want 4 buffers that you're going to write into. You will give me somewhere where I can write some pointers. But I will let you know that I'm going to mmap those buffers in. And then they just take each of those buffers and they initialize them with mmap here. Or they can say, hey, I want to use malloc to get those buffers. And then they do the same shit, but with malloc. Okay, so let's see if we have the user pointer one, because that one seems easier to me. So it's what? User buff cap supports user pointer? That doesn't seem right. I guess it's... I think that they're on initialization. They just checked if it was streaming. Okay. So we'll say that we want streaming. Streaming. Okay. Cool. And then they ask for crop capabilities. I don't really understand why you would need to do this. Select video input, video standard, and tune here. What if we just don't? We'll just use it in whatever state it's in. That seems fine. Then what do? They are saying, hey, I want... Oh, they just ask for the video format here. That makes sense. So you say, hey, what do you want to give me? And then I'll make sure that I'm like allocating enough bytes for that thing. Okay, sure. Seems reasonable. So here, we need to add to our fancy ioctal generator another one, which is vid IOCG format. What is your format? Okay. Which then we can say, oh, boom, oopsies, wrong paste. This paste is the one I want. So we can say, let format is equal to unsafe. And we do this thing again, but we replace some of the things. So this query cap is vid IOCG format, get format, with the same file descriptor. And instead of capabilities here, we are asking for format. This is a v4l2 format, I assume. What is this type here? Format is v4l2 format. And this is format and format. Okay. And then we can print the format. Print it. He doesn't like that. Oh, that's interesting. So capabilities, for some reason, had debug on him, but v4l2 format does not. But, okay. Weird. But we can... I don't understand why, but that's okay. But then they extract... I think they extract, like, the amount of size that they need from that. So they say, what? G format. And size image looks like what they get out. So we can just look at that. So we can say format.pix.size image. And we'll say image size is this. So cargo run, I guess. Access to union field. What the fuck? Oh, we just need an unsafe on here. Okay. And then they didn't like that we passed in an invalid argument at 47. That's interesting. So what did we fuck up here? Oh, we have to specify the type here. Ah, okay. So instead of this being a maybe uninit thing, we actually have to make this a zeroed thing. And then we say format dot type is equal to v4l2, and this is type underscore because type is reserved word, and v4l2 buff type video capture. So I guess is it like this? How do I get the pointer out? Oh, this seems like it's working. Okay. So I guess that this could be many different things. Like you could use this to extract like audio data or something. And this should be stood mem zeroed or something. Okay, that's running. Go to run. Okay, and we do get an image size out. I don't know if it makes sense, but we'll see, I guess. And okay, let's look at what this call does, because I want to know now. Vid IOC G format. Used to negotiate the format of data. To query the current parameters set blah blah blah. When we call the G format octal with the point of the structure, the driver fills in the respective number of the format. In the case of video capture devices, that is either struct v4l2 pix format or struct the blah blah blah. Okay. That's pretty cool. Pretty cool. So I guess, I wonder, in Rust, I don't know if it's like valid for me to like partially initialize this struct. So I guess I just won't, but I guess theoretically you don't need to zero out the whole format section. Let's see if we can like deduce if this pixel size, if this like image size is correct. So this guy has a format, which has a pixel format, and none of the rest of this stuff seems like it would affect the size. So then we can just look at here. Well, we can look at the width, height, and pixel format and see if those things line up. So we can say image width, height, format, pixel format, and sure, that's fine. And we'll just say this is format pix dot width, format pix height, format pix pixel format. And let's see if that all lines up. So we have 800 by 600 with this pixel format, and so we actually have to look up what these pixel formats might be. Presumably there's like some sort of like define for like YUV or RGB or something like that. Aha, yeah. Which probably don't resolve here, which is super cool. Super cool. Right, like probably if we say v4l2, v4l2 pix format. Yeah, these just aren't fucking resolved. So we have to go back into our GCC trick. And I guess this isn't print ioctal, but this is just a print define. And we'll call this v4l2 pix format. I guess we actually kind of want to just print them all. That's a lot of pixel formats. Holy. Okay. Maybe that's all of them? Oh, we actually missed some from up here. Jesus. Okay. Pix format, pix format, pix format, pix format, pix format, pix format. Holy. Okay. Copy. Paste. We go through this section and we say delete any lines that do not start with define. Okay. And then we can say I want to take define, then white space, then remember like non-white space characters. So it's like what, A to Z, 0 to 9 underscore. Okay. So we want all of this and then everything else. And we're going to replace that with the thing that we had. That's not working. Why the fuck not? Maybe the star goes in here. Aha, yeah, there we go. Nice. We did it. Okay, and then for all of these things, we say print define. And then we go here and we go all to the end, and we replace oopsies. Put some things at the end. Oh. We need to define the type here probably. So these guys think that their the format specifier is wrong. They expect unsigned in, but we try to print long unsigned in. So I guess we'll say LU. And then here we'll just say print define U. Which is a little annoying, but it's fine. Not the end of the world. Okay. So when we run our thing, we get this number, and let's just look for which one that is. We are pixel format MJPEG. Okay. What does that mean? What does that mean? MJPEG. I guess we can just look up what the fuck is an MJPEG. Video compression format, which each video frame is compressed separately as a JPEG image. Okay. So, does that mean I can just parse the thing as a JPEG? They're claiming that these are different things. Which is, I guess, what that guy was asking. He's like, what the fuck is the difference between an MJPEG and a JPEG for an individual frame? I agree. This guy's just like, I also don't know. That's not helpful. Okay, who... Was there a comment? Like, was there a useful comment on there? MJPEG. Compressed formats. What does it mean? Motion JPEG. I guess we'll find out, though. Motion... parse motion JPEG. Read MJPEG frame. Fuck it. I guess we'll just move forward and see what happens. Okay. So we now know that our thing is a MJPEG. So let's, I guess, assert that that stays true. Because it's the only thing we support. For now. Because it's the only thing we've seen. We only support what we've seen. So we'll say, assert that format pixel format is equal to v4l2 pix format mjpeg. Oh, we actually have to fix our generator script here because he is saving these as U64s and they should be U32s in this case. MJPEG. So I guess we can just change it to a U32 here manually. Okay. Okie dokie. So we have our thing. He requires unsafe, sure. And we click on run, and we're chilling. Okay. Okay. So if our pixel format is MJPEG, they're saying that we need this image size. And I guess it's not as simple as just getting like RGB out. So we can't just like calculate the size by saying, well, 800 times 600 times 4 is like less than or bigger than that number. But I guess we can assume that if JPEG is compressed, we can assume that this big number is bigger, and it is. 800 times 600, let's say like 800 times 600 is already half this size. So they're assuming 2 bytes per pixel and just hoping to God it fits in that, I guess. Or maybe the JPEG compression is turned up till it does. Okay. Okay. So let's see. Now that we have opened the device, we can look at what else do they do here? Do they do anything? They initialize the device. Oh, we have to allocate the memory. Right. So here we want to init the user pointer. Which means another unsafe block. And we're going to request some buffers. So we're going to say let mute buffrec is equal to. I guess we have to say that this is a v4l2 request buffers. And this is going to be zeroed out. And these, we can use their defaults for now. Fuck off, man. So we have to generate a couple more. A couple more of these guys. So which ones are they? They're this and this. This is super cool. Print define you. GCC gen. Here we go. Very cool, very cool, very cool, very cool. Oops. Here we go. And these guys no longer have these v4l2 shits in front of them. Cool. And what do they do next? What do they do? So they request the buffers, and they call an ioctl to request the buffer, which certainly means we're going to need this as well. This is vid ioc rec buffs. And there we go. There we go. So we call the ioctl with this guy. Oops. Here we go. Here we go. I feel like ads everywhere, not just on Twitch. We've really ramped up recently. I guess you can't hear me because the ad's still running. But yeah, it's it's fucking annoying. I agree. So, oh my god. I keep just pasting the wrong thing. There we go. Rec buffs. We get the buffs, and we say, here is our buffer request. And we pass it in like this. And we unwrap it. Oh, you did hear me. Sweet. It said that they were still running, but I guess you got hit with a slightly less than the maximum. Okay, so we run this. And I guess we can see now, does this fucking work? So it does. That's cool. Which means that we should just be able to loop over the buffers. We should be able to say that we want, how do we do this? We want to store, we want like somewhere in memory to store the output. So I guess maybe we should like start making a class here. Ah, fuck it. For now, we'll just put a vector. So we'll say let mute buffs is equal to vec new. And each internal thing, each buffer is going to be the size that the pixel says it is. So we're going to allocate 4 buffers of this size image. Where does this, like, end buffers here, they're just setting it to 4 additionally, so we can say, like, const num buffers is a u size equal to 4. Here we just say num buffers here. And I guess probably they want a u32 here instead. Yeah. And then we say for buff in buffs. Nope. For I in 0 to num buffers, we buffs push a new vec full of zeros with format pix size image. And I guess this is a, we don't know the type, this is probably a 0u8, I guess. That's how many bytes it is. And this should be try into unwrap to make it a u size. And I guess we can say let image size equal to unsafe this, because it's complaining again that like this is accessing some like fucked fields. So we'll just through a union, and Rust goes like, I don't like unions because they're unsafe. And it's like, that's pretty reasonable. I don't like unions either because they're unsafe. I agree, buddy. Okay. So here we can say image size, trying to unwrap. And we are chilling now. We're chilling. And so now, what did they do here? Their buffers. Oh, that's size of buffers. What the fuck is a buffers? Buffer is a buffer. What the fuck is a buffer? Buffer is a start and length. Oh, sure. This doesn't fucking... So they are getting... They're doing C-style vector allocation here. So they're requesting 4 buffers. And then each one of those, they're mallocing in a new thing. And the buffer size is just always... We know that the buffer size is what they passed in. Yeah, okay. Cool, so we don't have to worry about that. So here we just say, here are our buffers. And do they give those to the driver at all? Like, so they request the buffers here. But then do they not... They don't assign these buffers back to the driver in any way. So how does the driver know to write to these pointers? Probably, I guess, when we read. I guess. So we probably only need 1, to be honest. We probably only need 1. Maybe 2. We'll start with 1, and we'll just kind of see what fucking happens. And this actually doesn't have to happen until down here. Oh, but the driver is expecting them to loop through 4. Okay, sure. We do pass in this to the count. So I guess we'll see when we start trying to read what happens. So then, to start the capture... Ah! Here we go. Okay, so here they are assigning the buffer back into the... They're telling the driver, here's where you can write memory to. Or write to memory. Write pixels to memory. So we can say for I in 0 num buffers. Or I guess here we can say buffs len. We don't really need to... That way the num buffers doesn't like leak around, and if we change it... Oh, whatever, it doesn't really fucking matter. It doesn't matter. Okay, for I and 0 to num buffers, we are going to run some unsafe code, because we're interacting with the outside world. The outside world is scary and unsafe. Watch out for white vans. We say let v4l buff is equal to v4l is a... This is going to be a v4l2 buffer. And we want to start with it zeroed. Okay. White vans are fun as long as there's no wolf howling at the moon on the side. Okay. So we're going to do all this same shit. So we're going to say... What are these? What is all this? They're saying, hey, this is a buffer, and his usage is we are expecting this to be a buffer for video. Okay. Here, they're saying the buffer is a user pointer in memory. That makes sense. They're saying, hey, driver, just so you know, this is like my pointer, and so you have to do some handling in the kernel driver to support that. Here is the index of that thing. And here we're saying this is as pointer. Buffers I is buffs here. Buffs I as pointer. So here is where you can write to. And here is the length of the thing, which is buffs I.len. Here is the maximum length of that thing. So he doesn't like that this is U32, so I guess here we'll write buffs len so that just the types line up better. And Oh, but this is expecting a U32. Okay, fine, whatever. It's fine. It's fine. It's fine. It's fine. As usize for both of these. Cool. I guess we can even do it once. Let buff is equal to buffs I as usize. We can take like a reference to him. Yeah, sure. Okay, so this is getting kind of sketchy too because now this stuff can change under our like without us knowing, which is kind of weird. So technically we're probably supposed to use unsafe cells here to say, or maybe even volatile to say like, hey, Rust, don't fucking assume that you know what's going on here. So we're gonna put fix me here and say unsafe cell around each buff question mark. So I don't really know how that works, and I'll have to figure that out. This probably has to be as I64 as U64. Okay, and this is length is a U32, so we say as U32. Okay, then we say this guy's mutable. And then we call an ioctl. Ioctl fd vid ioc q buff, which is not query buffer, this is q buffer. And we are doing this for each buffer. So this is and v4l buff like this. And we need to then, you know, generate the ioctl number for vid ioc q buff. Easy. Which is this guy. Oops. This guy like this. And presumably these also have to be generated. Cargo check. Yep, neither of those. Oh. Yeah, neither of those guys made it, so. Oi, oi, oi. So we have to generate those as well. It's like at this point, what is binding even doing for, you know? Print define you this. And what was the other one again? I already forgot it. v4l2 memory user pointer. All right. Oh, that one's already here. Oh, we already did both these. I'm just fucking high. What is it not liking then? Cannot assign because it's not mutable? Oh, I'm high. There we go. There we go. Okay. So now we should be able to just start streaming. Right? That's what I think they're saying here. Once we have defined all of those things, we say, turn the stream on, bitch. So this is ioctl, this, and what is type here? v4l2 buff type. Where does this get assigned? v4l type is equal to v4l2 buff type video capture. Okay, I mean, what? There's no other option here. Okay, whatever. Whatever, this is v4l2 buff type video capture. And I guess this needs to be an address, or say let video capture buff type is equal to this. And pass in video capture buff type. And I guess maybe we even have to say that this is a v4l2 buff type, because I'm worried about like the memory representation of this guy being like the right size. Okay, and then we can unwrap this. And theoretically, at this point, we should be running. But we need to get the vid IOC stream on thing. Print define LU. Fuck me, dude. There's so many like different pastes. I have like 4 clipboards, right? You have like the X normal copy paste clipboard. I have my Tmux clipboard, my Vim clipboards, and then like the X11 secondary clipboard. And I just like fucking keep pasting the wrong one. I'm gonna lose my fucking mind. Really, I should just use the same one every time, but I just don't for some fucking reason. Okay. So now, SEA thread sleep 1.0 F32 sleep S sleep MS. Jesus, I just want to sleep, man. Sleep for 1 second. I just want to see if we fucking crash. Okay. So now, theoretically, we've like started streaming, and something is happening. Except I don't see my the light of my webcam's on, and then it immediately turns off. Hold on. Let's sleep for 10 seconds. The light of my webcam is on, consistently on. Okay. So it does look like it's working. And then I'm curious to see. So say we drop buffs here. I'm going to assume that I'm going to segfault in that case, right? Because what should happen in that case is the video driver will try to write to these pointers that we no longer own. And I expect that to be a problem. And it's not, which is kind of scary. Maybe it only starts trying to write if we request a read. So here, when we say our main loop, they say, hey, could you let me know when you are available for reading? So can we do that on our file descriptor in Rust? Is there like an equivalent to select in Rust? File. Is there like a, maybe like on the read trait, there's gotta be some sort of like, are you ready? So you can read into a buffer, which isn't really what we're doing, right? We're kind of more trying to poll. Is there like a poll in here? Rust poll file descriptor. MIO. What about like in the standard library? There's got to be something in the standard library. So this guy's using Tokyo. Poll in file descriptor. Nix source poll. What do they do? So they create like a libc poll fd and then call events. Poll fd events. Maybe I do just have to fucking call poll, which is annoying. Oh, gross. All right. Is it man2 select? Are they like the same? Select monitors file description file descriptors to monitor multiple file descriptors, waiting until one or more is ready. But we only have one, so we don't really care. What's the difference between poll and select again? Poll is similar to select. It waits for a set of file descriptors to become ready to perform IO. I can never fucking remember. Oh, I guess we can look at what the Rust standard library does for TCP sockets. Certainly they have like a similar thing in there. They must have something. So they have a TCP stream, and when they call receive, someone has a receive. UDP socket receive, sure. Fuck it. They call self 0 receive. Cool. Cool. But what does that do? I guess we need to actually look at the fucking... fine. Can I, like... use stud net UDP socket and jump to definition here. Look at this. What do they do when they, like, receive? Self inner receive from. What do they do? Receive from with flags. libc receive from. Oh, okay, so they just call into libc. Fine. Fine. Is there like a try receive? Or on like TCP stream? What do they do? Try. There's no. I see. So they just have. It's probably the same shit. Yeah, they're just calling libc receive. Okay. Which means that I just need to call select myself. Does select make sense versus poll versus select Linux? I can never fucking remember. Select has you create 3 bit masks to mark which socket file descriptors you want to watch for reading, writing, and errors. Poll has you create a list of descriptor IDs. Can I like poll 1 socket? Poll 1 FD Linux. I just want to know if there's like a better, like a simpler API to use. But looks like no. Okay, whatever. We'll just use select because they used select in their example. And it does look like we don't have an option but to wait for this. So in our main loop, we're going to, first we, in our wrapper, we need to include wherever select comes from. So we have that API, sysselect, of course. Cargo, okay. So now we go back into our main and we delete this line for a second, cargo build. Okay, and so now v4l2 select should exist, nice. Why are they doing FD plus 1 here? FD set, FDs. What the fuck? Ugh, that seems complicated. What the fuck? Man to select. Int number of FDs. FD set. Okay, this sounds man to poll. That's simpler. This takes in poll FD star FDs. That seems simpler. So I've changed my mind. We're going to poll because select seems like I need to use macros to set the set and stuff like that. So fuck that noise. Fuck that. Okay, so we're gonna say include poll.h. Cargo build. And we are going to look at the poll API. So I guess, what are we gonna do? What are we gonna do? We're gonna split here, man to poll. We have v4l2 poll FDs. Poll. Why is the poll FD not in there? Did I cargo build? I did. So if I go to v4l2 poll, and I jump to definition on this, he doesn't like that. Provide the arguments. Okay, so let FD is equal to v4l2 poll FD. Probably this is going to be like an array of these guys. One of them. We're going to have one FD. Okay, this is going to be FD. And my indexer doesn't like this for some reason. So I'm just going to quit and cargo build, open it again. Hopefully then this jump to definition will work. Why? Oh, there. Now it's working. There we go. Okay, so this is FD events are events. Okay, so we are going to allocate an array of these things that are going to look like this. FD is FD. And then we have to look at the registered events. So I guess events is going to be v4l2 poll in. I guess there's data ready to read. And what's the other thing I need? and R events. What is that? What is that? The R events is an output parameter. Ah, okay. So here we can just say R events is 0. And this guy is expecting an I16, so as I16. And then we call poll. And hopefully, this will tell us if we're ready to go. So he takes in FD as pointer, FD len. This should be a poll FD, I guess. Poll FD, and we have a timeout. So we'll just put 1. I don't know. I don't fucking know, man. And what does he return? Or can I set the timeout to 0? I guess to say like fucking go forever. Number of milliseconds should pull. The call will block until either this thing. It'll be rounded up to the system clock granularity, specifying a negative value as an infinite timeout. That's what I want. Okay. And what is my return value? On success, it returns a non-negative value, which is a number of elements in the poll FD where our events fields have been set to a non-zero value. Okay, so for I guess what we'll just do for now is we'll just in a loop print this what this returns, and hopefully we should see it spam not that much. That's kind of what I'm hoping. Cargo check. I think it's bitching about something. FD as pointer as U64, I guess is what it wants. No, what is poll takes in a pointer to poll FDs. Oh, as mute pointer, I guess. Because this thing can be changed. And is it len that wants a U64? Here we go. Cool. And then hopefully this only prints like once per frame. But oh shit, I guess we actually have to read for the poll thing to clear. Yeah, we do. I think we do have to read it for the thing to happen. So we can go back into our test.c now. And we have to read the thing, which means we have to call this uint pointer. So we have a buff, v4l2 buffer. Let v4l2 buff is equal to v4l2 buffer. And I guess we do it like this. We say it's a zeroed out thing. And v4l2 buff type is equal to this. We actually already did this. It's this stuff here. Boom. And what are they doing here? They say, I want to dequeue a buffer. And how do we know which buffer we got? Here they're saying, oh, I see. So they give us the buffer here. Okay, sure. So we say v4l. So first we run the octal to dequeue the buffer with v4l2 buff like this. Okay, this means this has to be mutable, and probably we should write v4l2 buff mute here as well. We need the dequeue buff thing, the define, so we can say gcc gen thing, which now we say dequeue buff instead of queue buff. Like this, easy. Oops. We paste that here. This will now work for this guy. This guy needs to be v4l2 buff. We unwrap this guy to make sure he didn't fail. And then we should be chilling. Should be. So this, if I run this, okay, so we dequeued 4 buffers and then gave up, which is pretty interesting. So that, I bet you that correlates with this number of buffers. So if I dequeue 10 buffers, we'll probably get to 10 and then it'll stop. So probably what happens here actually is we've queued up 4 buffers and said, here's what you can write to. And then when we dequeue them, we say, okay, we're looking at them. And then we probably have to queue them again when we're done. So, woohoo, yep, here we go. I could have just read this, but instead I guessed, and we did guess correctly. So here, we can just requeue the buffer. Yeah. And now we are reading at what seems to be a reasonable rate. And it's continuing on. So I think we've got a pretty good guess. We're pretty set up here. And so now all we have to do is like figure out what the fuck do we do with this image? And so probably, if I understand this correctly, the fact that it's mjpeg means that we should just be able to process the frame as a JPEG, I think, unless mjpeg has some sort of like encoding over time, which I don't think it does. mjpeg. I think it's just each frame or interlaced field of a digital sequence is compressed separately as a JPEG image. Yeah, so it's just a bunch of JPEGs, according to this. So we should be able to maybe like import cargo add like the image crate. And we should be able to just look at the memory of that shit. So we should be able to say, hey, I want this pointer. Please give it to me. And we'll parse this as a slice. We'll say se slice from raw parts. And we'll take the pointer and the length of it. So this is buff.length, I guess. Yep. And we'll say let JPEG is equal to this. So this should be a slice of U8 or something. Let's give him a sec. He's got to compile all of these image crate stuff. And he doesn't like that because he doesn't know. Oh, this is expected U size, found a U3 so it's as U size. Does that fix it? No, because the user pointer is type U64, so we'll just cast this to a bunch of U8s. Okay. And then we should be able to say image from, like, image. We should be able to, like, parse this JPEG. Image docs.rs. We should be able to load from bytes. Load from memory. With format, probably. Well, let's try load from memory. And just, like, see what the fuck happens here. So load from memory does return an image result. And let's just see if this fuck crashes. It might. Yeah. Ooh, segfault. That's surprising. Where is that segfault coming from? Ah, okay, so trying to read that buffer is fucking dying because we dropped the buffers here. Because we were trying to prove a segfault earlier and we just forgot. Sick, okay. So now we should be able to call this load from everything without segfaulting, but it might fail. Yeah, so it does. It says, hey, Oh. Okay, so they correctly figured out that it was a JPEG. Which means that the header of the thing is looking correctly. And they're saying, format scan makes use of unset DC Huffman table. Okay. So how the fuck do we populate that? That's interesting. Maybe we can Google this error and see if anybody will just tell me the answer. JPEG. So this guy says, hey, Oh, this is exactly what I was trying to do. Once I added a Huffman table from another JPEG with a hex editor. This is the problem. So it seems like JPEG standards define some Huffman tables, and that's how these guys are able to decode them. I ran some tests, and adding the default Huffman tables when none are provided fixes this case. Add support for decoding MJPEG frames. So this is image.rs JPEG decoder, but maybe image itself does not work. So maybe we pull in JPEG decoder instead, which the image crate relies on. And maybe this just hasn't made it all the way up here. Cargo, add JPEG decoder. JPEG decoder on cargo. Let's just make sure that's like the fucking right thing, which it looks like it is. And what does this guy even do? Add support for decoding MJPEG frames. So here there's a thing called fill default MJPEG tables, and do I have to do that myself? It does kind of look like that, hey? Decoder. Right, like I don't see anywhere where this thing is called. Oh no, they must call it in here. Oh yeah, if self is MJPEG. Is MJPEG is false. Oh, so we just have to specifically ask for an MJPEG. Probably. Is MJPEG. Nope. Is MJPEG. Maybe they automatically figure this out. Decoder. It does look like they just probably figure that shit out, hey? Yeah, it does look like it. Okay. So let's just try that. So we'll say JPEG decoder. How do you use this thing? Read info. Okay, let's just try this. So we use a JPEG decoder, decoder new, and we just pass in this JPEG. And then we read info. Let info, it's equal to this. We say print line, the info, please. What the fuck is you? You know? Let's see if that gives me anything interesting. So that's... Oh, I see. We have to read the info and then decoder info unwrap. We print line this. Like this. Like this, like this, like this. Alright, that's a really good sign. So we did in fact get an image info that's 800 by 600, and then how do we actually get the data? We call decode, which returns a new vector of U8's decoded as what? What are the decoded pixels here? Oh, I guess it depends on here. So here they're saying it's RGB24. So they'll probably give me chunks of RGB by doing that. Decoder, decode. Unwrap. Let RGB is equal to this. And then we can say print line RGB len. Let's just like as a sanity check. Okay, scan makes use of an unset DC Huffman table. So why? Okay, so we're missing something here. We are definitely missing something. Does decoder have debug on him? No. So onset, what is it? Huffman fill default MJPEG tables. Okay, so probably is mjpeg is not being set because they depend on application data. Okay. So that comes from a marker. Do I get to set that? Like, who... do I get to do that? JPEG decoder. Or is that something that they're deriving from the file that is not being correctly set? Oh, it does look like maybe the marker comes from pending marker. Pending marker none. So what, they look for something in the data. Oh, that's annoying. That's so annoying. So it looks like they basically ask for internals. Like the JPEG decoder is trying to decide what it sees. And that thing is not being flagged correctly. And so this fill... Okay, what if, here, hear me out. What if we just copy paste the implementation of this and then run it ourselves? That seems possible. Because, like, sure, maybe the camera isn't correctly flagging that, but maybe we can. So this comes from Huffman. And we can say fill default tables. And... oh, but then you need to pass in the right fucking things. Oh, what a pain in my ass. Okay, what if we say fuck MJPEGs? What if instead of MJPEGs we just put the camera into YUV mode? Surely we can. I'm pretty sure that we can. So we can maybe ask what formats are supported and then set it up that way. Probably. So where do we see MJPEG? Here on the pixel format. So here we can say set, and then to get this we call G format. So I think there's an S format that you can set. And here they specifically asked for YUV, like this. So I guess what we can do is we can say test help. We can say test-f, and that now I'll bet you when we run our thing, our camera will be in YUV 420 mode because the other thing configured it for us. Hell yeah. And then we just say fuck you MJPEG. So we expect YUVV. Yeah. Okay. Okay. And then we can just try to write the frame out. So we need to go into our thing here and wherever we wrote mjpeg. Oh, we already have it here. So we should be able to say gen ioctals, look for YUIV, which is this guy. We'll assert him instead. Here, we'll say we only support YUIV, which means here. We put this guy here. Say, fuck you, MJPEG. Okay. And then let's just dump the frame out. So instead of doing this like decoder shit, we can just take the buffer. We still need the slice. And this is going to be buff. And then we can just dump the buffer somewhere. So file, open, test YUV. And I guess we need open options, new, with right permissions, create true. When we open test YUV, let output is equal to this, and then we say output dot output.write. Hello? You need to use IO_write, I guess. Oh, we need to unwrap, I guess. So please succeed in opening this file, and then output.write all. Let's write the whole thing. We'll write the whole buffer to test YUV, and then we'll return. So here we should have a frame. Fuck! What's happening now? What just changed? 136. How odd. It just like didn't work after, if that was after return, but whatever. Okay. So now we have a YUV image. And then I think there's like YUV view is something that I've used before. YU view. YUV viewer. GIMP? Can I open it with GIMP? Test.YUV unknown file type. I know that there's like a way to like view YUV Linux. I'm sure that I've done this before. YUView. Yeah, this is what I've used before. But maybe this just isn't bundled in NixOS. YUView. Oh, nice. Okay. So nix shell -p libs. Libs for Qt5 is a crazy name for this, but sure, whatever. whatever. We can look at YUView. What? No? Where does this go? Hello? YUView. What am I missing? Am I high? It says it's here. Name YUView. Source. Oh, maybe it's YUView. Ah. Of course. So this guy thinks this is... Oh, do I click open here? Bitstream analysis? No bitstream. Select a bitstream file. Open file. What is happening? Item view. This has worked for me before. But it does look like it just doesn't think anything's here. Number of frames 1, bytes per frame 0. So it just like, why am I not seeing anything here? Oh, I need to set the width and height. Okay. Loading. Okay, we're close. YU420. Bytes per frame. This file size does not match. Okay. 4440. What like custom bit depth 10? I guess we don't really know. We don't really know what it thinks it is. Does the Linux command file tell you what the file? I mean, file works by looking at like headers and seeing what it expects. Like it looks for like magic identifiers. But here we're just like dumping out a bucket of bytes, so we can't really expect that to work. I don't think. Let's see. We should be able to do. Oh, first let's unwrap this to make sure the write succeeds, just in case, which it does. And we have a. Oh, it's 640 by 480. That's why. Nix shell -p YUView. I just typed the wrong thing. I typed 800 by 600 for some reason. Maybe because that's what it was configured at before. So we can open file, test YUV, and this should be 640, 480. Oh, here we go. Hell yeah, baby. Okay. So now we can try to figure out what fucking format is this thing in. Let's look at Y only, maybe. So here you can tell we're kind of close. You can kind of see the top of my head in here, but it's not really like the interlacing is wrong here. So I think we said was YU YV or something. How do we figure out bit depth? chroma subsampling, maybe it's 444. We should just, instead of just randomly fucking guessing, maybe we can actually look at what we fucking typed. So in test.c, YUIV, so they did field interlaced. They set it up as interlaced YUV. So can I like jump to this and see like what is interlaced? Both fields are interlaced. And what is YUIV? This is YUV422. Okay. So that's what? 4 bytes for color? No, 4 bits for color, then 2 bits for U, and then 2 bits for V. What is like YUV422? Like, what the fuck is this? I need to refresh my memory. How often U and V are sampled relative to Y? 444 means no sampling. 422 means 2-to-1 horizontal downsampling with no vertical downsampling. Every scan line contains 4 Y samples for every 2 U or V samples. Okay, so then are they interlaced? So we did say interlaced in the somewhere in here. It said interlaced. So here we said field interlaced, which means that probably you get 4 Y samples followed by 2 chroma and 2 U and 2 V, where U and V are like, I don't remember, purple and yellow or some shit. I don't remember. Okay, so let's open YUV again here. And we should be at 422 8-bit. Frame size 640 by 480. It does feel like this is wrong. It does feel like this width should be higher. Right? Because like, why am I not seeing like my head in the top left over here? What does this do? Oh, I see. I feel like we're missing something. Oh, interleaved. No. Maybe it's different bit depth? Maybe it's... Oh, YUIV. Here we go. This is what I'm looking for. YUIV. There it is. Let's go, baby. Wow. Look at me go. I look good. Okay. Okay, so we do, in fact, have a video frame, and it is not, this is the mistake here, is it's not planar, as in we don't have all Ys, then all Us, then all Vs. We have Y, U, U, V, V, probably. All values are stored by pixels. There are 2 Y values, 1 chroma U and 1 chroma V value packed per pixel. But then what is like a pixel here? I don't feel like I understand the like interleaved format. Because like when you have planar, it makes sense to me, right? You have like your data here is like luma here in like the shape of your image, right? So you have like 640 by like 480, right? And this is all like luma, 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 luma. And then they kind of like pack in 240. I guess I kind of pack it like this. So here you have like U and V, where these guys are like quarter resolution, or half resolution, I should say, of this guy. I think if you have 2. Oh, I guess maybe the chroma is like, how is this? Because like usually what I thought would happen is that like, you have like 4 pixels for luminance, 1, 2, 3, 4, and then like 1 UV for like this whole 2x2 block. But that doesn't actually line up because they're saying that you should have 2 for every 4. So maybe what they're actually doing is they're saying they're going in a row. And they're going like Y, U, Y, V, Y, U, Y, V. Ah, that does make sense. Okay, so that's why this is packing orders Y, U, Y, V. So every other byte, you're getting 1 of U or V, and you're probably like combining them for like this whole section. So this pixel gets like, each pixel gets the U and V from the previous one or something. Probably. Okay, that makes sense. That makes sense. So now, I guess, what do we want to do? We're at 2 hours, so we're kind of sitting at the edge of what's reasonable. And like the next thing to do would probably be to like get a video of the webcam running in like our UI, and probably we would need to like reformat this code a little bit to kind of like be in some struct that you can like pull for more data, etc. But for now, I think that's pretty good. So we got to the point where we read a single frame and we exported it, and we can open it in YUV. So we understand like in YUV. So we understand like the data format. We understand like interaction with the kernel driver. And the thing that we're missing is like just sequential access to that thing. So I think that's pretty cool. I'm going to call it there for today. Thanks for watching. If you like what you saw, I stream most days around 1 or 2 o'clock Pacific time for 1 or 2 hours. We've been covering like a variety of topics. If you're watching on YouTube and you want to swing by on Twitch, there's a Twitch link in the YouTube description. If you're watching on Twitch and you want to swing by on YouTube, there's a YouTube link in the Twitch description. Otherwise, I think that's it for now, and thanks for watching. Catch you all in the next one. Bye!